Hello guys, how you doing? Hope everybody is having a great day. We are gonna start heading into midterm one material. I'm gonna cover all of midterm one material. Midterm two material is already covered. Then I will be covering the last 3 weeks lectures, and that should be your exam review for calculus review. Then we'll start diving into physics and covering all physics materials, then computer architecture, C++, and all the other stuff. So right now we're heading into this is the first lecture of Calc 2, and we are going to go into techniques of integration, and the first one is going to be integration by parts. This is the longest form of integration, and it's the form of integration that applies to any type of integration you do. But obviously, like we said, it's the longest form, and so you want to avoid this at all costs unless you have to. All right, so we're going to start with first two examples here. We have the integral of x and x plus 1. How would you integrate this? What technique would you use? So far, from Calc 1, the only technique you learned is your u sub. You make your u as something and you sub it in. And when do you use u sub? Whenever you have a function, so this is technically a function, multiplying another function, that causes you a problem and it's hard to integrate because of the product rule. So you know when we derive, if I have x squared, actually x squared is, yeah, actually let's do x squared times cos x. All right. When you want to derive this, what you'll do is you'll integrate your left side. You'll get 2x. Then you'll keep the right side the same. Then what you'll do is you'll do plus, and then leave the left side the same, and integrate the right. Right. I believe this is negative. And you leave the right. And so how do you undo this in your integral? Because remember, integrals are undoing your derivative. And so what you can do in this case, you can either u sub, but that will give you back the same thing basically. So the first thing you can do is just FOIL. And so you get x squared plus x. And now this is one function. You don't have it multiplying, they're adding. When they add, that's fine. Because when they add, you can basically use the integral identity of doing the integral of x squared plus the integral of x. And you separate your integrals into two parts, and you'll get x3 divided by 3 plus your x2 divided by 2, right? And so this part you can just FOIL and turn it into one function. Now the other thing is with the one below is that we can't really FOIL this, and it's two functions multiplying. So what can we do? There's something called a u sub, which is you can bring a letter, and I'm going to choose u, and you can make it to anything you want. But usually, obviously, you want something inside here. And it's like, well, what should I choose for my u? If I choose for my u x, right? So I choose x. This x will get replaced by u, and this x will get replaced by u squared. That's the same thing. We didn't go anywhere. So that's a bad idea. Now, if I make my u e to the x squared, this whole thing replaces by u, but how am I going to replace this x? That won't work. So how about I do x squared? U equals x squared. All right. Now that will replace this, and I know that the integral of e to the x is e to the x, right? So integral of e to the x is e to the x plus c, right? And so I know if I change this x squared to u, I can integrate. How can I get rid of my x? Now I can, well, the thing is, if I just replace that, so if I do this, that is now in terms of u and x, and I can't really do much. So how about I introduce a du? How can I introduce a du? If I integrate my u, I get a du. Sorry, if I derive my u, I get a du. Remember, your du comes from deriving. So if I give you just a function like y equals x squared, and you derive this, what you'll get is you'll get 2x dx, right? That's you're telling the person I derived this is a derivative function. And so what I can do is derive this, so I'll get du. Obviously, when I derive u, I get du. The same thing here, you'll get dy on the left side. And so I could derive this, I get du. And I could derive this, I'll get 2x dx. Okay, so I now introduce a second, you can think about like formula or equation or function or derivative, right? I introduce a second thing. And now I can sub this in because these equal the same thing. So if I take this 2 to the other side, it'll be du over 2. equals x dx. These two are equivalent to each other in this context. So what I can say is, since here I have an x dx, can't I just replace my d over 2? Because my x dx equals d over 2 is the same thing. So if it's the same thing, can't I just replace it? And the answer is yes. So you'll get e to the u, and since I replaced it, I get du over 2. And now to integrate this, what will happen is I'll continue here. When you integrate this, what will happen is you can take a constant that's multiplied, not a constant that's added, a constant that's multiplied. So if I rewrite this, it's e to the u 1 over 2 du, right? This is the same thing. And if you have a constant that's multiplied, you can just take it out. So 1 over 2 eu du. And we said the integral of eu is just eu. So 1 over 2 eu plus c, right? And now you have to take it back in terms of x. So I get 1 over 2 e to the x squared plus c. And that's how you integrate in your u sub. And he says now we will continue to investigate more advanced integration techniques to make your integral easier. All right, and this only happens with practice. You have to practice integrating if you want to get really good at it. You can't really just memorize it. You can't just understand it. You have to practice. So now we will continue to investigate more advanced integration techniques where our previous methods won't work. And this is one of them. Now, x sine x. How can we, integrate this? And the question is, well, I can't expand. If I u sub x, then this will just be integral of u sine u, du, let's say. After I drive, I get du equals dx. And that's just the same thing. So, well, that doesn't work. Well, what if I put my sine as u, right? So sine x, right? And then I integrate and I get du equals cos x, right? I'm like, okay, let me replace stuff. So here I'll do, so I'll sub in my u, which is x stays because I don't have anything for x. And then I have u because I subbed in u for sine x. And my dx I can't really replace, so I'll keep that. Okay, so what else I can do? This is dx here. You can isolate du divided by cos x, but this is a mess. You have u in terms of x, and you can't really get rid of x. And you can't really just get rid of u. You can't really integrate x sine x. So, well, what do we do here? And that is where we introduce integration by part. Integration by part is, like I said earlier, is the longest integral, and you want to avoid it at all costs. So your u sub is very short. It's very simple. Integration is like your first principle of a derivative. It'll work with almost any function, but the problem is it's very long. So there's shorter ways. You want to always find the shorter way, but if you don't, you could use this. And so what does this say? It says that your function f of x times your g of x, g derivative of x. So you know how we said this is x sine x? This is one function multiplying the other. So you can assume this is your f of x, and this is your g of x. All right. This is horrible drawing, but okay. And or you can also say g of x is x, and you can say my f of x is sine. It doesn't matter of the order. All right. So the question is, well, how do you use this? All right, and we're gonna go into it right now. The function, you can remember it as u dv, your dv. Okay, so we introduced two variables, u and v, and so u equals your f of x, right? Your u equals your f of x, which is your first function. Your dv, remember how we said dv or dx comes from the derivative of something? So dv equals the derivative of your g of x. And that means if I integrate my g derivative of x, what I'll get is g of x, right? If I integrate it. And if I integrate my dv, I get v. So your v is your g, right? Actually, let me put it in order. So your v is your x, your u is your f of x, and that means your du is your f derivative of x, right? and this function is given. No, sorry, this formula is given, and if you but you'll use it enough that you probably remember it, so you probably won't need to refer. So now the question is, well, how do you apply it here? How do you choose? So what you do is you want to choose something as your u, and you want to choose something as your v, and something as your dv, and something as your du. It's like, well, how do you pick? There's something that is going to be taught down here. I don't know why she didn't teach this first, so I'm going to go down here, then come up here. And so this word is called liyate, and just remember this word. And the word says is L for log, I for inverse trig, oh, these trig, right? Your A, I actually forgot for your A for a log inverse algebraic, so algebraic, or whatever the word is. And what it says is, your x squared, this is algebraic. T for your trig, and E for your exponential. Okay, now what the hell does this word mean? What is this log inverse? Okay, algebraic. What this is, it says which one gets the u. So you know how we have u, and we have v, and we have du, and we have dv? What this says is which one of these get the u first. So in your function, you know how I had x sine x? This x is algebraic. Algebraic. All right? And your sine x is trig, right? Trig. And so what this says is the first letter in the word, the first letter in my liyate, whichever comes first. So you see here, my algebraic comes first in the equation. So that's my A. A comes first because trig is after. So that means your first one gets your u. All right? So the first one gets my u. So u equals x. That means du equals dx. And what I did here, I just derived the left side and right side. So the derivative of x is dx, the derivative of u is du. All right? Now, the other thing is, well, if your u gets your x, what you'll say is then my dv, not v, my dv gets the rest of it, which is sine x. All right? And obviously, we also had a dx, so it would be sine x dx. Now what you want to do is you want to choose your v, and your v is the integral of this. When you integrate your sine x, you get cos x d. Oh, what? Oops. You get your cos x. That's it, because this is integral. And you integrate this, and you get v cos x. All right? Now what do? You take this that we just identified each variable, and you sub it into this equation up here. So I'm going to solve it down here so we can also see the equation. Can I move this? No? Okay. Why do they allow me to move it? But it snaps back. That is dumb. Anyways, so my x, we said u equals x because x comes first. And then my du is just the derivative of my u, which is dx. And then we said then the rest of the equation gets dv. So if there was another cos, this my dv will be sine x cos x. Well, obviously there's only the sine x left and the dx. So you take the whole thing and you equal it to your dv, so dx. That means my v is the integral of this, and the integral of this is just cos x. I'm trying to remember if it's negative cos x. I think it's negative cos x. The integral of sine is negative cos x. Okay, so now you sub into this equation, and my equation says the integral of u dv equals my uv minus the integral of my v du. All right, so let's apply that. Equals my u x, right? My v, that's cos x, negative cos x. So this will be the whole thing. Will be negative u v, or what? Oh my god, the negative x cos x. So I apply my negative minus the integral of v, negative cos x, and du. What's my du? dx. All right. Now this negative goes outside, cancels out with this negative, making a positive. Negative x cos x plus the integral cos x dx. and now you just integrate normally. Your left side is already integrated, plus my integral of cos x, which is sine x, and plus c, obviously. And that is my integral for something that you don't know how to integrate. You can use your integration by part, the longest form of integration, and that will get you your answer almost always. It's just very long. And so now that we know how to choose, you can look at these examples and choose. And so you can see this is trig, this is algebraic, so my x is u, as it comes first, and my trig goes second. All right, here, this is exponential, comes last. X, so x takes my u because it comes first. Exponential comes last in the lyote, so it goes to dv. Here, what this actually looks like if you rewrite it is ln x 1 over root x, right? And so, well, what comes first? Ln x comes first. So we have ln x, and we have, so if we write this, if you want to rewrite this, what you'll get is x to the negative 1 over 2. So this is actually algebraic. All right, ln x is just is a log, right? And so log comes first, and algebraic comes second. So this would take my, and it's pretty straightforward, I'd say. But don't forget, your dv takes the whole thing that's left. And that would be your dx included. Same thing here. Okay. Now, another example here says, do it. I'm not going to do these because this should be practice. Also, the solution is on lecture. And so that's why I won't be covering it. Because this is just extra practice for you guys to do. All right. I'm just here to really explain concepts. And so integration by part of a definite is you just take, so you see here, we go up to our example earlier. I'm going to rewrite it here and zoom in. So I get equals my negative x cos x plus my sine x plus c, right? Assuming this is a definite integral, which means, let's say, integrate, okay, so let's say I go up here and it says integrate from 1 to 2, right? How do you integrate? When you integrate, like when you have a definite integral, you don't get a plus c, right? And what you'll get is, first, when I took this out, right? When I took this out right here, you still have to apply your bounds to this. And so you'll say is negative x cos x, you apply the bounds from 1 to 2, all right, plus my sine x, which is also from 1 to 2, right? So I can combine these two, negative x cos x, oops, plus sine x from 1 to 2, all right? Now, another thing I could do is I can take this whole thing. So before I integrate the right side, what I had is, if you look here, look at this example. So, you know, my right side is still from 1 to 2. This side is also from 1 to 2. And that's how you could write it. And that's what this says, is that when you do integration by part, don't forget you have to integrate your left side that you took out and your right side. All right. So here, if the rate of change of medication in the bloodstream is dA over dt, what is the net change in the amount of medication from time t 0 time t? So as soon as you have your dA over dt, this is what basically saying it's a prime equals t squared times e to the negative t. And what this says is that this function is a derivative. I can't spell derivative. It's a derivative, right? That's because you have your dA over dt. Now, how can I integrate this? Because they want the net change. All right, what net change, it means, let's say I have player A ran 10 miles. And player B ran 5 miles. What is the net change? What you'll do is you take the long side, your A. I'll say, okay, my A minus my player B. equals my net change between the two players. And that would equal 5 miles, right? And so that's basically what integrating is. When you do an integral, so if I were to do this in integral terms, well, I'll say, okay, then I'm going from 5 to 10, which means my a, after you integrate, what will happen is you'll get, what happened to my, after you take this, of this whole situation, what you'll get is, same thing, your a at 5 minus your b at 10, and, well, your a, sorry, at 10 minus your b at 5, and so on. And so, how can I integrate this? You cannot integrate if I don't have a dt. So remember, this is in terms of t. So I need a dt. So I have dA over dt. What I could say is dA. Alright, I'm just rewriting it. I'm going to take dt to the other side. Now, I can integrate and get the change, which is from 0 to 1 of my t squared e to the negative t dt. And now you can, what do you call it? Now you can integrate this. I'm not going to go through how you integrate this because we just went through an example above. Use integration by part and integrate. All right. Here, I think is more practice. Sometimes you can apply integration by parts, even though you're only integrating a single function. So how can you do it here? Can we integrate ln x? So you know how I said integral of e to the x is just e to the x, and that one is basically given in the formula sheet. It's known. So you don't need to know it. Your ln x, however, is not given, and you do have to integrate it properly. I don't think it's given from what I remember. But if you want to integrate your ln x, what you could say is you can do integration by part. And so Liate says the first thing that comes is log, right? And so this is log, right? And so you get my ln x and my du. We know how to derive ln x, which is 1 over x dx, right? And then I can say my dv gets the rest. What's rest? This is the only thing that's left. And that means my v equals x. And now I can sub it into the equation. And the equation says uv, so u is ln x, v, which is x, so x minus the integral of my u, or sorry, so if I can go back, yeah, of my v du. So my v is x, my du is 1 over x dx. Now these two cancel out, giving you just 1. Right, so you'll get ln x, do it like, that looks weird, so I think I'm gonna reverse it. My x, I know I put y, oops, ln x minus the integral of dx. Because this turns into a 1, and you can basically remove the 1, because the 1 times dx is just dx. And then this will get you x ln x minus the integral of just dx is x. Alright, because when you integrate a constant, this will be x. Alright, and this technically is a 1 here. Alright, plus your c. And occasionally, okay, so occasionally in this example, you have to go in circles. And what do you do when you go in circles? You keep going until your left side equals your right side. So let's integrate this. And what will happen here is I'll use my Liate. I don't know how to integrate this without Liate. I can't use up this. So Li okay. And so this is exponential. And this is trig. Trig comes before exponential, so my u equals my trig. And du equals cos dx. Now the rest gets my dv. So e to the x dx, right? And then my v is the integral of e to the x, which is just e to the x. All right. Now sub it into the equation. The equation tells us this is your equation. This is for bounds though, so we're not taking bounds here. Integral of u dv or sorry, UDU? Yeah, UDV equals UV minus VDU. All right, now let's sub everything in. It says the integral of my sine x e to the x dx equals uv, which is where am I? uv sine x e to the x, all right, minus my v du, which, well, the integral, my integral of v du, which is e to the x, and my du is cos dx. Now I gotta integrate this. This side stays. When I integrate this, this is the same as integrating this. It's just instead of sine, it's cos. So what do? Use this again. So let's see. U equals my trig, which right now it's cos x. Then I'll say my du equals the derivative of this, which is, right? Trying to remember if sine is a negative, guys. Does anyone know if sine is a negative? Derivative of sine is cos x, and the derivative of cos x is negative sine. Yes. Okay. And now my dv equals what's left, which is e to the x dx, and my v gets the derivative of e to the x. The derivative of e to the x is the same, e to the x. And now let me sub this back in. So everything on the left side stays the same. Minus the integral of this. So if I take this to the side and write it, it will be uv minus, obviously, this equation, v du. And now when I sub it in, I'll get cos x. I don't know why I'm slow today. E to the x. I'm just subbing stuff in. The integral of v, which is e to the x, and du, which is negative. So this will become plus sine x dx. All right. And so we got our left side. So what I'm going to do is I'm going to sub it in. Our left side is cos x e to the x plus the integral of my e to the x sine x dx. And we're back where we left from. Right? And so if I do this, I'll get this again. Well, what do I do here? All right. Here's what I'm going to do. Let me expand. All right. So I'm going to expand here and get rid of my ugly looking brackets. This negative goes in, minus. And then this negative goes in, minus. Right? Now that my bracket is done, like I said, if I integrate this one more time, I'll get the same as my last integral, which is this, and I'll be going in loops. And that is never ending. But this left side equals, well, it doesn't equal, but it's the same as this. So what if I take this to the other side, and this is negative, right? So if I take it to the other side, well, I'll get a ln sine x e to the x dx plus the derivative of e to the x. As this goes to the other side, this becomes positive. Sine x dx equals sine x e to the x minus cos x e to the x. Now if I add these, this is the same as saying two integrals of sine x ex dx equals sine x ex minus cos x. And now I can just divide by 2. So I'll say the integral of sine e to the x dx, oops, there's an x here, equals sine x e to the x minus cos x e to the x all over 2. And so now we solved it. It says what is the integral of e to the x sine x? And I said it here, sine x e to the x dx equals to this integral. That's what happens when you go in loops. You want to wait until your left side equals something from your right, equals the integral from the right, and you take the other side. Don't forget to divide by 2 or however many integrals you're adding.